Okay, the last section in chapter 4 is exponential and logarithmic equations. We talked about the rules for applying them, so now we need to figure out how to evaluate equations using our skills and approximating the calculator when necessary. And mostly on the test, I'll have you leave it in its most reduced non-calculator form, but sometimes your homework will have you put it in the calculator to get a decimal approximation. As an example, 7 to the x equals 12. I need to get x by itself. So I can take the logarithm of both sides. Log of 7 to the x equals log of 12. Use my exponent rules and logarithms to bring the x out front, and divide by the log of 7 in order to get this decimal approximation of 1.277. On the test, I would have you leave it here. But if you need a decimal approximation, you can use your calculator for this. Now, you can ignore example 1. It's harder than anything you'll have to see. It's rather unnecessary. So we'll go ahead and move to the next page. So let's start with base E exponential equations. So to isolate a variable and an exponent attached to E, you take the natural logs of both sides. This will allow us to bring the x squared out, and the ln of E is 1. So the ln and the E essentially cancel each other out. From there, you can solve for the variable. Now, you can never take the logarithm or natural log of a negative number is the most important thing. If you get an answer when you plug back in, like the log of -5, you have to throw it out. It's not a solution. So we have e to the x squared equals 200. We take the ln of both sides. So the ln of e to the x squared equals the ln of 200. The ln and the e cancel out. Inverse operations, x squared equals the ln of 200. And then we get x equals, we would normally say plus or minus square root of the ln of 200 after taking the square root. We need to make sure that makes sense though, because it's x squared in the parentheses, it should be totally fine. Because squaring a negative will go back to positive, that's not an issue. Okay, if you've got multiple instances of e, you need to use your exponent rules to get them all together into a single e term. So when I'm multiplying with the same base, I add the exponents. So this is e to the 2x plus 1 plus that negative 4x equals 3e. Now 2x plus negative 4x is negative 2x. And I need all my e's on one side, so I need to divide by e here. Remember, this is e to the first, so negative 2x plus 1 minus 1 is just e to the negative 2x equals 3. Take the ln of both sides. So negative 2x equals the ln of 3, and divide by negative 2. So x is negative 1/2 times the ln of 3, or the negative ln of 3 over 2. Now we have some equations which are quadratic form. You can't combine them because there's not multiplication, there's adding or subtracting. So here we have to be clever. This is really e to the 2x minus 4e to the x plus 3 equals 0. This is going to behave like a quadratic. How? I have to factor this, and we'll see what that means in a second. But before that, we can use what we call u substitution. Let u equal e to the x. Remember that e to the 2x is really e to the x squared. Which means when I put u in, this becomes u squared minus 4u plus 3 equals 0. This is something you can factor. It factors into u minus 3 and u minus 1, which means either u equals 3 or u equals 1. Now, since I didn't start the problem with u, I can't end it with u. I've got to go back to e to the x. So e to the x equals 3, e to the x equals 1. Okay, take the ln of both sides, and we get x equals the ln of 3, or x equals the ln of 1. Now, any logarithm of 1 is 0, so we have our two answers, the ln of 3 and 0. We can plug them back in to make sure it works. Anything to the 0 power is 0, so I get 1, or is 1, so 1 minus 4 is negative 3. That works. I want to check the other thing. E to the 2 times the ln of 3 minus 4e to the ln of 3. equals -3. It also works. You have to use a little bit of your rules to show that it does, but I promise that it does work. 4 is the same. I'll leave that one for you guys to work on, and we can go to the next page. Besides equations with e as a base, we also have logarithmic equations. To solve logarithmic equations, you try to get all your logarithms in a single log using your condensed rules, and try to rewrite it in exponential form if you can, and then check your answers because, again, we're not allowed to have any negatives inside logarithms. So 7 times the ln of x equals 28. Let's divide by 7 to get the ln of x equals 4. To get rid of an ln, we can rewrite this in log form. So that, remember, this is log base e, so that it's e to the 4th equals x, and you're just done. However, the way that this actually works, just like we can take the ln of both sides, we actually can take e raised to both sides to cancel out the ln, so that these two will cancel, and we have x equals e to the 4th that way as well. So while we could take the ln of both sides, we really take e and raise it to a power to get rid of a logarithm. If it were log base 2, we would have to take 2 raised to the power in order to get rid of it. So log base 2 of x cubed minus 19 equals 3. If I were to use that other strategy I just talked about, I would say 2 to this power equals 2 to the 3rd. 2 and log base 2 cancel, so that x cubed minus 19 equals 2 cubed, which is 8. Add the 19 over to get x cubed equals 27. And to get rid of the cube, we take the cube root. Cube root of x cubed equals the cube root of 27, which means x equals 3. Now again, I would plug this back in just to make sure. 3 cubed is 27. 27 minus 19 is 8. So I don't have a negative number inside the logarithm, so it should be fine. Now let's look at 3. Log of x plus 6 minus log of x plus 2 equals log of x. I need to get all my logarithms in one side, or on the one side into the same log. Subtraction becomes division. X plus 6 over x plus 2 equals log x. Now, this is a log base 10, so I'm going to take 10 raised to each side. It cancels out the logarithm and the 10, so I get x plus 6 over x plus 2 equals x. I'm going to multiply the x plus 2 to the other side. I can do this because if the answer was -2, it can't go into the logarithm. It would create negatives, so I know it's already thrown out. So x plus 6 equals x times x plus 2, which means x plus 6 equals x squared plus 2x. This is now quadratic. I need to get everything to one side. So I'm now factoring x squared plus x minus 6. Factors into x plus 3, x minus 2. So either x equals -3 or x equals 2. So these are the types of equations that I really need to go back and make sure that they work when I plug them in. -3 plus 6 is positive, so that's fine. -3 plus 2 is negative. I can't have a negative inside a logarithm, so that breaks this logarithm. And -3 over here by itself also doesn't work. So this one's out. Well, we plug in 2. 2 plus 6 is 8. 2 plus 2 is 4. And here it's just 2, so this one's fine. So it's just the one solution. So again, you can't have negatives inside the logarithm. And we will continue in the next video.